Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Current trends and drivers of spacecraft ground segment virtualization, enablers of end-to-end cloud-based service delivery. Spacecraft ground segment, a segment responsible for command and control, telemetry and data reception, mission operations, data processing and distribution, maintenance and support. In this era of agile constellations of small satellites, serves as the brain behind space mission successes. Based on the rise of large LEO constellations of software-defined satellites, the spacecraft ground segment is rapidly moving away from its traditional hardware-centric model to software-defined functions. The current trends and drivers of spacecraft ground segment virtualization are enablers of the ground segment migration towards fully integrated end-to-end cloud-based service delivery, and uses of software and cloud technologies to decouple ground segment hardware from the operational software. They help to create agile, flexible, and scalable new ground infrastructure. The major trends are shift from hardware to software, adoption of cloud and edge computing, growth of ground segment as a service, digitalization with radio frequency, and increased automation and AI and machine learning. The focus points are as follows: LEO constellations and software-defined spacecraft, and current trends and drivers of spacecraft ground segment virtualization. LEO constellations and software-defined spacecraft. LEO constellations are large groups of satellites in low Earth orbit that work together for global coverage, while software-defined spacecraft use onboard software to dynamically adjust their functions, enabling flexibility and upgrades over time. The two concepts are converging with software-defined satellites, providing the advanced control necessary for managing the complex network of LEO constellations, optimizing performance, and adding new capabilities, such as improved data processing and communication pathways through software updates. LEO satellite constellations Starlink, OneWeb, Upcom, and Iridium are shown in this picture. Rise of LEO constellation. Driven by the rise of large LEO constellations and software-defined satellites, spacecraft ground segment is rapidly moving away from a traditional hardware-centric model. The primary trend is the virtualization of ground stations, which uses software and cloud technologies in order to decouple hardware from the operational software. This creates an agile, flexible, and scalable new ground infrastructure. Low Earth orbit constellation is shown in this picture. Current trends and drivers of spacecraft ground segment virtualization are software-defined ground stations, cloud and commodity hardware, growth of ground segment as a service, digitization with radio frequency, increased automation and artificial intelligence and machine learning, integration with 5G and terrestrial networks, and standardization and open architecture, and adoption of cloud and edge computing. Software-defined ground stations. Presently, there is a move away from physical hardware towards software-based systems which can adapt to different satellites, frequency bands, and applications seamlessly. This enables dynamic and flexible operations. Ground data system and mission operation is illustrated in this system. Cloud and commodity hardware. Virtualization is being enabled by leveraging cloud platforms and standard off-the-shelf hardware. This significantly reduces capital expenditure and allows for on-demand resource allocation. Satellite ground network digitization is illustrated in this picture. Adoption of cloud and edge computing. Major cloud providers such as Amazon, Microsoft Azure offer dedicated ground station services which integrate ground segment operations directly into the cloud. Application of AI to every phase of space operation is shown in this picture. Cloud and edge deployment. Satellite operators can schedule satellite contacts that link data and immediately process it using advanced cloud-based analytics. For use cases requiring ultra-low latency, some processing can happen at the edge, physical ground station sites. Copernicus ground segment is illustrated in this picture. The expansion of low Earth orbit and medium Earth orbit constellation from new space startups has fueled the ground station as a service model, where third-party providers offer ground station access on a pay-per-use or subscription basis. This brings satellite approach democratizes access to space. Traditional versus ground station as a service model. Digitization with radio frequency over IP. Analog RF signals from antennas are converted to digital streams and transported over IP. This decouples the antenna from processing hardware. Select ground segment facilitates worldwide. It's shown in this picture. Increased automation and machine learning. Virtualized ground systems are being enhanced with artificial intelligence and machine learning in order to automate complex operations. Network topology of a satellite command and control system is shown in this system. Integration with 5G and terrestrial networks. As the satellite industry moves toward a multi-orbit, multi-access environment, virtualization is enabling the integration of satellite ground networks with the broader terrestrial telecommunications and 5G ecosystem. Integrated ground system is shown in this system. Standardization and open architecture. The industry is moving towards open standards-based systems to address limitation of proprietary hardware. The Digital IF Interoperability Consortium is a notable example. Galileo ground segment is shown in this picture. For more information, contact Astronautics for Exploits. You've been listening to Current Trends and Drivers of Spacecraft Ground Segment Virtualization, Enablers of End-to-End Cloud-Based Service Delivery by Dr. Ayoshala Ogundele, with the focus points LEO constellations and software-defined spacecraft, and current trends and drivers of spacecraft ground segment virtualization. Thank you.